Thank you very much. I'm going to try to use my presentation more than anything else to introduce the topic and hopefully give some of my time to Bob Buchanan, who's considerably longer-winded than I am. No, actually, he actually has more data than I do. When I started my career in the food industry, it was not at all uncommon to manage microbiological risk by going out and taking a 25-gram sample of food, culturing it for salmonella, getting a negative result, and calling it good to go. I go back, I think about that. There were times we did get positives, which probably tells you it must have been really bad because, that's an exceptionally lousy sampling plan. And things got better when the FDA BAM manual pushed much better salmonella sampling plans based on the risk posed by the food. Something like infant formula, you'd get 60 25-gram subsamples. Something like a food that was going to get cooked, you'd get 15 25-gram subsamples. And although most of the industry did not adhere to that for a very long time, I don't think it was until the 1990s that companies began to look at a 25-gram sample size as ridiculously small. We now live in an era where if you can find a pathogen in a food ready to eat, and in some cases otherwise, by any sample method, size, or test method, it could be deemed adulterated. And our ability to detect pathogens has improved so that I've gotten to the point, and I know everyone at the agency that has come before and after me, you worry that you are throwing away food that would do no harm. You're worried about having more objectivity in deciding what kind of sampling plan to use and what is going to be the threshold for acceptance. I think we would all acknowledge it is not a pathogen-free world. But when I was with the agency, if a product came under investigation and we felt it necessary to collect thousands of grams of that product to sample and test it, we could do that. And if we found the pathogen in there, particularly a pathogen that matched a clinical case, well, you clearly had a product that was causing illness. and I wrestled with that, and I know my successors and predecessors wrestled with that. So I'll tell you a little bit about the historical approach. And we in the title of this, we talk about regulatory changes. You know, technological changes have been every bit as impactful as regulatory changes, and maybe more so. And then I'll give you some thoughts on how I think we ought to begin to deal with this. For one thing, the U.S., for good or for evil, we have very few quantitative regulatory standards. In the U.S., we don't have to, for every food, specify a count or a limit. The focus of U.S. regulators has always been on pathogens, always been on adulteration, and under U.S. law, if you can show that a food, particularly a ready-to-eat food, has a harmful pathogen in it in an amount that would be expected to cause harm, then that food's adulterated. And we haven't had to have everything spelled out, and we have very few regulations that talk about things like E. coli and coliforms in foods. And in truth, the agency doesn't do, if you looked at the body of the testing done by the agency, it's going to be for pathogens. It's not for indicator type organisms. And one of the problems I've always had, and I think some others in my field, is the use of the term zero tolerance. We have never had, in truth, zero tolerance. What we have had is an utter lack of transparency in setting tolerances, okay? Whenever you have a method, and you can refer to the BAM manual of decades ago even, whenever you have a method that spells out a sample size and a test method, it's possible to look at that and calculate the number below which you're expected to get a negative result. That amounts to a tolerance. And tolerances typically were set based on the feasibility to collect the sample and do the test, or if we happen to know it, a public health need. If you look at the standards for powdered infant formula, which have been in existence for decades, requiring that a manufacturer test 60 25-gram subsamples, if you do the math, then within a 95% confidence interval, if you get a negative result in that test, then that means you have fewer than one cell in 510 grams. Does that mean the agency thinks that infant formula with less than one salmonella in 510 grams, let's say only 1 in 1,000 grams, would be safe? Oh, hell no. We have 9 billion servings of infant formula in the U.S. a year. If that was all you did, we'd have one heck of a lot of infant salmonellosis. So clearly, that is not a standard that was based on a public health need. That was a standard based on what reasonably could be expected of the industry for each lot of product. But it wasn't zero tolerance. So what zero tolerance really is it's zero tolerance for a positive result by whatever method you use. And that's what we've had. Here's some examples of some standards that we do have. If you look at non-fat dry milk, not more than 10,000 standard plate count, 10 coliforms, salmonella, negative in 400 grams. Again, these standards are, in the case of the standard plate count and coliforms, that is a hygiene indicator. And any powdered milk producer worth their salt ought to be way below those. I routinely see powdered milk with no more than 500 per gram standard plate count, no coliforms, and certainly we expect salmonella to be much more scarce than just negative in 400 grams. But these are clearly limits that if you were above those limits as a producer, you've got problems. You know, that's not a product to be proud of. And then there's our infant formula example. And then we have, for cheese, an ICMSF approach for E. coli. But the U.S. has very few standards like this. It's great to have that flexibility as a regulator, but with that comes the situation we have here as to how good do I have to be to protect public health. So I think technological changes actually affected us more than regulatory, at least in the United States, because enumeration and detection methods have gotten better. Epidemiological investigation techniques have gotten better, and you have to consider that because that is how we get onto a lot of these foods in the first place. And PFGE typing caused a sea change in the regulatory mind. Prior to that PFGE typing, I don't think anyone in CDC or FDA had a clue as to how frequently we had disease-producing pathogens in processed foods. I mean, you got to realize, prior to that, most of the outbreaks we investigated were in large dining settings, like I can remember several school lunch program outbreaks, you know, and we simply had no idea. And whole genome sequencing has now taken this up another notch, so we're doing a better job too with outbreak investigations and identifying root causes. So there's been tremendous technological improvement in the understanding of where to find problems in foods and detecting problem foods. But there hasn't been any regulatory policy adjustment to all of that. In other words, if you find yourself as a regulator having to make decisions because an organism, a pathogen, has been found in a unprocessed, ready-to-eat food, you've got no guidelines to go by other than if the pathogen's there, the food must be adulterated. But these regulatory changes have affected us quite a bit too. I think one of the big things that has happened is increased environmental pathogen testing by regulators and by industry, because it is indirectly leading us to find pathogens in foods and link foods to outbreaks. We're actually able to link a food to an outbreak without ever finding the pathogen in the food. And probably if we tested the heck out of that food, might not find that pathogen in the food, but clearly at some point the food was contaminated and caused illness. I want to show you some data based on really large numbers of samples. This is some data collected by our firm. This data, I'm going to show you two charts. One is produce tested as it was in the field or immediately from the field, okay? And then produce tested after it had gone through some processing and was packaged as ready to eat. In each of these cases, we have more than 1,000 samples for the commodity, and some of them, like lettuce there, you see 141,000 samples. My point is, this is a really good sample size, and there's multiple companies in this, and these are all what I would call probably top-tier companies in terms of good agricultural practices, good processing practices. I believe that the data you see here is reflective of the real world for these products in the U.S. I believe it's reflective of what the best of the industry can do right now. And some of the interesting things you see here, very surprising that you get this high percent of positive for apple, that's raw and cored. Who'd have thought? Leafy greens. But if you go up and down this, you come out with a grand total over almost, hundreds of thousands of samples here of about 0.36% are positive for Salmonella, EHEC, or Listeria monocytogenes. That's the pathogen burden in these foods that are largely ready to eat and consumed without cooking by consumers. Okay, how good do we do after we go through our processing plants? I would imagine that a lot of people in my field would feel, based on scientific studies that have been done, as you go through washing and use of sanitizers and wash water and sorting, that you maybe get a log, 1 or 2 log reduction. Apparently not. About the best we do maybe is a 50% reduction in prevalence. I don't know what the reduction in numbers is. It could be a 1 or 2 log reduction, I don't know. But you get about a 50% reduction in prevalence. Somehow Brussels sprouts got up there at the top. I like my Brussels sprouts cooked, so. If you've ever eaten a raw Brussels sprout, it's nasty. I think this data very clearly shows it is not a pathogen-free world. And if this is really the best we can do we have information that says, in order to protect the public health, we need to do better? Do we know what that would cost? Is it reasonable to spend our public health dollars towards that cost? Or is it more reasonable to try to manage this risk with at-risk populations through education and closer monitoring? And should we not, if this is what is at this point, I hate to use the word unavoidable, if this is what's typically, the industry is typically capable of, should we not adjust our sampling plans and test methodologies so that if you are performing at this level, you would be unlikely to get a positive result? Right now, it's quite possible to go out, for a regulator to go out and take samples of these commodities at this level of contamination and occasionally find one that's contaminated, leading the company into a very costly recall and perhaps litigation. Here's another way of looking at some of this data. And again, this shows that depending on the commodity, you don't necessarily reduce the prevalence of the pathogen by going through the processing process. And I think that needs to be looked at. All of us would think and desire that if we compare something we take from the field and carry it through our manufacturing process, that the prevalence of pathogens should be no greater and perhaps even reduced. So I really can't explain some of these things except to say that on the industry side of things, there's a lot of room for work and improvement on managing it so that our processes do not make the problem worse. So we're finding pathogens in food more frequently. We're learning more about routes of contamination during growing, harvesting. By no means do we know what we need to know. We're seeing a lot more food recalls, and these recalls are phenomenally costly. If you have a national brand and you have to do a recall, about the best you can hope for is it'll cost you something less than $30 million, and it can easily cost you $100 million or more. And that's enough to break the back of a lot of companies. I think the thing we've got to do is start talking about adapting a regulatory risk management strategy, and that are typically not given a kill step prior to consumption. These produce items, those are going to, if you can do it at all with food, you ought to be able to do it with those foods, because you're not talking about a kill step in the hands of the consumer, and you don't have that additional uncertainty to deal with in quantitative risk assessment. So I really think we should focus on those foods, and if anybody in this room has a notion that all foods should be pathogen-free, you should disaffect yourself of that. I think that concept is doomed, and it's easily proven if you just sample and test enough. You're going to have to use a quantitative risk assessment approach here. It's going to be quite complex, but I think it's doable for this category of foods. And I think doing that, if we're able to set such I would call it more like a performance standard. If you're able to set a performance standard or action limit for these foods, I would never codify it in a regulation. You're going to be able to change that as we're able to innovate and get improvements in process to reduce the prevalence of pathogens. And having such a limit itself will actually cause the industry to focus on improvements that will allow them to consistently and easily meet such a limit. So at any rate, some of the things we need to do for this, clearly, is we need more data on pathogen exposure at the time of consumption. I was just talking to Mark Wirtz back here. One thing FDA used to do was they would collect food samples at retail, and then they would prepare those foods for consumption, and then on that food they would do pesticide residue testing, which gave the nation a fantastic database on pesticide exposure on foods as consumed. We don't have anything like that for microorganisms, and it would not be easy to do because in most cases those organisms would be few and far between and difficult to detect. But I think we've also got to consider that there is a cost to the industry, to the nation, to the government for food recalls, and we've got to figure out how we need to spend our money and whether or not we might be more effective with alternative risk management strategies. As I get older, I am surely mindful of my increased vulnerability to Listeria monocytogenes. Has it changed my eating habits? Yes, it has, but not everybody my age and older appreciates this, and they should. By the time you get really old, like, Bob, you're quite vulnerable. I'm feeling this way because my birthday was yesterday, so it's really weighing on me. I think we've got lots to learn, but now is the time to start diving into this, and these ready-to-eat food items are the ones to start with. Hopefully I left Bob a little time.
So after that wonderful enlightenment on the changing landscape, any questions? If you would please step up to the microphone. Yes, sir.
Dane Bernard, Bold Bear Food Safety. Don, thanks for the presentation. Maybe we could ask somebody to lower the microphones next time, but that's just a personal comment. Don, I appreciate the IEH data that you shared with us this morning. On leafy greens, does your data have a breakdown on organic versus non-organic?
He's asking a breakdown on organic versus non-organic. We could go back into the data set and do that, but I haven't done it. And I wouldn't even venture to predict what we'd find. I'm not that crazy.
Mark Curl from In-N-Out Burger. Don, thanks once again for a nice presentation. My question to you is, with that data set, by chance do you have the corresponding in-plant environmental data that may provide some insight as to before processing and after processing within the plant? Have you attempted to make those types of correlations and looked in the data in that fashion, if it's available?
I don't have the ability to line up environmental data for each of those plants. And I would caution against anyone jumping to the conclusion that because you see an increase in prevalence of contamination from the field to processing, it may not be due to environmental contamination from that plant. Because as you know, a lot of these things go through fluming and washing together. You could have a perfectly excellent environment and still come up with that kind of a result. It is difficult for a lot of these processors to maintain consistently effective levels of sanitizers that inactivate any organism quickly.
Other questions? Somebody stepping up.
There's one, Sunny Law from USDA. Your data actually matches what we've been told by some of the processors when they did their fresh cut processing. So I've been told that they were wondering why they have increased the bacterial population after wash, before wash. So I really want to thank you for that slide shared with us.
I don't know. I could only theorize. I think that's probably occurring when, bacteria on some items get transferred to items that didn't have it before. But I have to also say it may simply be due to some recovery of the organism or making them easier to isolate after going through that process. I simply don't know. And the one thing I've learned in a life of science is what seems to be perfectly logical could be utterly wrong,
Bob Sanderson, president of Jonathan Sprouts. I'm pleased not to see sprouts on your list, but I think it might have been a typo. And without shooting myself in the foot too much, because Brussels sprouts, as you said, who eats those without cooking? But it's nice to see sprouts just barely ahead of lettuce and leafy greens and stuff. So we're getting there. Thank you.
It is what it is.
Well, thank you, Don. How about a nice round of applause?